So we can do electron configurations to show where the electrons are in the orbitals. Or in the subshells and the shells, and we can also use orbital diagrams to get a little more specific and show the electrons in their orbitals. So you can draw a box for the orbital. I like to just draw a line, but whatever you want to do. So we have lithium there. Lithium has 3 electrons, so we put 2 in 1s and 1 in the 2s. So to represent that in an orbital diagram, there's the box for 1s, so we show an electron going up, 1 going down, and then the 2s, we show the electron going up. Then we have beryllium with 4 electrons, 2 in the 1s, 2 in the 2s. And again, same thing, we want to use the boxes or just a line to represent the orbitals and put the electrons in those orbitals. So boron then has an electron actually into a p subshell, so it only puts 1 electron in one of the p orbitals because that's all it has, but you still show all 3 orbitals in the p subshell. Let me give you another example here. So we're going to do the orbital diagram for phosphorus. So phosphorus has 15 electrons, and again, we're just getting that from the atomic number. So I like to do the electron configuration before I do an orbital diagram. That way I can see how many electrons are in each of the subshells. So we're going to put 2 in the 1s, 2 in the 2s, 6 in 2p, and then 2 in 3s, and then we have 3 left over. We're going to put them in 3p. So again, always start with your electron configuration before you start doing the orbital diagram. So for orbital diagrams, I like to draw lines. So the s subshell has 1 orbital, so I'm going to draw 1 line and label it 1s. And then again, 2s just has 1 orbital, but then 2p has 3 orbitals, so I'm going to draw 3 lines. And again, if you want to do boxes, that's fine. And then 3s, s only has 1 orbital, and then 3p with 3 lines. Okay, so the 1s only has 2 electrons, so I'm going to put 1 electron going up, 1 going down. And then 2s has 2 electrons, I'm going to put 1 going up, 1 going down. 2p has 6, so these are going to be all filled. 1 going up, 1 going down for each orbital. 3s has 2, 1 going up, 1 going down. And then 3p3. So this next part we're going to look at is Hund's rule. And Hund's rule tells us that the lower energy electron configuration is the one where the maximum number of electrons is unpaired. So basically what that means is, in order to get the lowest energy state possible, the best thing to do is to put 1 electron in the orbital, another one in the next, another one in the last, before we start to pair the electrons. Because anytime you get paired electrons, electrons are negative, and so you get the electron-electron repulsion. So to get the lowest energy state possible, it's best to put 1 electron in each of the orbitals, and they have to have the same spin. So it looks like that. So another example here is nitrogen. Nitrogen has 3 electrons in 2p, and again we put 1 in each of the orbitals with the same spin to get the lowest energy state possible. That's always what the goal is, to get the lower energy state. Okay, we're going to do orbital diagrams for these electron configurations that we drew earlier. So first, helium. So we know helium had a 1s. So 1s2. Oops. I always get too high. Okay, so we're only going to draw 1 line because s only has 1 orbital. And we're going to put 1 electron going up, 1 going down. And then oxygen, we saw had 1s2, 2s2, and 2p4, had 4 electrons, or 8 electrons total. So we're going to draw 1s and 2s, and then 3 lines for 2p because it has 3 orbitals. So we're going to put 2 in the 1s, 2 in the 2s, and then here's how we follow Hund's rule. Put 1, 2, 3 electrons, and now we can begin to pair. So we'll pair that very first orbital. Okay, and then sodium, we had 1s2, 2s2, 2p6, 3s2, 3p6. Oh, no, I went too far. Sorry, just 3s1. Has 11 electrons. Okay, so then we're going to do 1s, 2s, 2p, and 3s. Okay, so we'll have an electron going up and down in the 1s, up and down in the 2s, and then 2p is completely filled, so I'm just going to go ahead and fill them up, and then 1s only has 1. Okay, last one is iron. So iron, we had 1s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, so S only has 1, and then P has 3, 3s, 3p, 4s, and then D has 5. 1, 2, 3, 4, 5. Okay, so now we can put in our electrons. 1s has 2, 2s has 2, and 2p has 6. 3s has 2, 3p has 6. 4s has 2, and 3d has 6. So here we want to follow Hund's rule. So we're going to put 1 electron in each orbital to get the lowest energy state, and then we have 1 more, so we're going to pair it with that first one.